The Pythagorean theorem originated about 2000 years ago by a man named Pythagoras in ancient Greece. Pythagoras found out that if a triangle had a 90-degree angle and you placed the squares on each side of the triangle, the area of the two smaller squares, A and B, would be equal to the largest square, the one of the hypotenuse. Nowadays, the method has been converted into a formula which reads a to the second power plus b to the second power equals c to the second power. All triangles have, divided among its three sides, 180 degrees. Since right triangles must have, forcefully, a 90-degree angle, we only need to find the measurement of the other two angles, which together must measure 90 degrees as well. The three main functions of trigonometry are sine, cosine, and tangent, which are helpful to determine the ratio of sides in a right triangle. Sine is the division of the opposite side and the hypotenuse. The cosine is the division of the adjacent side with the hypotenuse, and the tangent is the division of the opposite side and the adjacent. There are also the called opposites of sine, cosine, and tangent, which are cosecant, secant, and cotangent. We call them opposites because they are the inverse of the sine, cosine, and tangent answers. In this project, we will identify two right triangles in our environment and determine the size of its sides and angles, and their trigonometric functions and their opposites. Also, we will measure our shadows and with the help of the solar calculator, we will find our height and compare it to our real height in order to see how exact it is.
To determine Bernardo's height, we first needed to know the measurement of the shadow, which is 2.25 meters, and the angle of elevation of the sun, which is 38.63 degrees. Then, we use the formula of tan to find the missing side, the one with the x, that according to the angle from the sun was the opposite side. To find Jorge's height, we measured the shadow, which was 2.09 meters. Then, we used the same measurement of the angle of elevation from Bernardo's question, which was 38.63 degrees. In this problem, we used tan function too, as the sides we used were the opposite and the adjacent, needing to find the opposite, which was Jorge's height. In the first section of the project, we realized that the right triangles are everywhere on our environment and can be made or designed in several situations that can help us solve doubts or pieces of information that are not easy to find. With the second section, this project teaches us that with some studying, people can be able, depending on the region, to identify the time where a picture was taken depending on the angle of elevation from the sun, even though we did the process otherwise. Choose the location and time to find the angle of elevation. Now, it is easier to understand why trigonometry can be used in satellite navigation, composition of music, and digital imaging. So, as a conclusion, we can state that math will be in our lives every day, and each time we are teaching a new topic, it is important to analyze how it can be used in real life. as we will encounter a problem involving them in the future. If people keep rejecting math or blocking themselves to not learn, their life will become more difficult.